Hello, 8th graders. Your video is covering section 8.5, which is on dilations. And so a dilation is another type of transformation. When you dilate something, you think of your eyes and how your pupil dilates. It gets bigger and it gets smaller, right? So transformation is a change where the figure and its image are similar. And that means that it's the same shape. It's not going to change shapes, but it is going to change sizes. And so to be able to do a dilation, you have to use a scale factor, which is the ratio. So it's a fraction, in other words. It could be a whole number if it comes out that way. The ratio of a length in the image to the corresponding length of the original figure. So how does one figure compare to the other one? How much bigger or how much smaller is the new image does it have to be? So if you want to find the dilation of an object, if the origin is the center, you can use this rule. You're going to multiply all of the coordinates by the scale factor if the scale factor is over 1. If the scale factor is less than 1, you're actually going to end up dividing, or you could multiply by a fraction. It depends what it looks like. Like if the scale factor is 1/2, you would divide them all by 2. But if the scale factor was something different that didn't come out even like that, you might want to just multiply it by a decimal, and then it would get smaller. So for this one, for my first example here, it says find the image of triangle DEF. So I've already drawn the pre-image there, and then I'm going to go through the steps of how we're going to change it. So it says find the image of the triangle DEF with vertices D, E, and F, and I already put those on there, after a dilation with a center D and a scale factor of 2. So you got to be careful on this one because it does not say the origin is the center. So I can't just multiply, I can't just take -2, 2, multiply -2 times 2 and get -4. That's not how it works. Not when it's center. When a point is the center, it's done differently. Okay? Saying that D is the center means that D has to stay where D started. Okay? D does not move. So your new D is exactly where the old D is. Okay, so that's D, and it's also D1. So DF, how do I make that twice as big? Well, how big is it right now? It's 1, 2, 3 units long. So then if I double it, it needs to be 6 units. So 4, 5, 6. So my new F is going to be down here. It's F1. My D to E, again, because it's diagonal, it's a little different. So what I'm going to do, instead of measuring this diagonal, I'm going to measure this one because it's straight. This one would be pretty hard to do because you'd have to do the a squared, b squared, c squared, find the distance, and then double it, and it might end up kind of messy. So we're going to use this one. So it's 1, 2, 3 long. So I need to make F, the new F to the new E, I need to make 6 long then. I need to double it. So 1, 2, 3, 4, 5, 6. There is my new E. And so then I will just connect it. And so there you can see that triangle got twice as big. Okay. So since D is the center, you're going to double all the sides, but D stays in the same place because it is the center. That's just what I said, right? I'm just writing it out here. So DF is 3 units, which is what I said. D to F is 3 units, and because it said a scale factor of 2, I had to double it. So instead of 3, I made it 6. The same thing here. F to E was 3, and so to double it, I made it 6, and then there's my new image. So that's what you do when it says a point is the center. The whatever point they tell you does not move, the other ones move, and then you just connect your new one. So then let's do one where the origin is the center, and I'll show you what the difference is here. Okay, so for this one, it says find the coordinates of the vertices. So find the new corners, right? The image of the quadrilateral KLMN, in which I have already drawn here, KLMN I've already drawn, after a dilation with a scale factor of 3/2. So 1.5, in other words, is probably going to be easier to use than 3/2, right? To do 3/2, I'd have to take it times 3 and divide it by 2. So it'd be easier just to change it to a decimal, since that comes out nice. All right, so I wrote down the coordinates here of my original points, M, N, L, and K. And then, since I need to do a scale factor of 3/2, I'm going to multiply them all times 1.5, right? So times 1.5. So 1 times 1.5 is 1.5. So I'm going to have 1.5, 1.5 for my new point. If I take both of these times 1.5, I'm going to get 1.5 and negative 1.5. And I'm going to take these times 1/2, 1.5, and these times 1.5. So 4 times 1.5 would be 4, and then half would be 2, so it would be negative 6, and then negative 1.5. 2 times 1.5 would be 3, so negative 3 and 1.5. See? You see how that's way different than what I did up here? Up here I just said, okay, how long is this? I need to double it. How long is this? I need to double it. That's because the point, this point was the center. But now the origin is the center, so I have to take each point and multiply it by whatever it says. If my scale factor would have been 1/2, I would have divided each one of these by 2. Okay? So here's my new point, so I can go ahead and graph them then. So I have 1.5 and 1.5. So it's going to kind of almost overlap. It's not getting a large amount bigger. Not getting very much bigger. So L is negative 3. So 1, 2, 3, and 1.5. There's my new L. My new N, 1.5, negative 1.5. Again, it's pretty close to the original. And my new K is 1, 2, 3, 4, 5, 6, and negative 1.5. It's out here. So that's a little further away. So then I connect my new points, and you can see that the old image, the pre-image, is inside of the new image. So it's 1.5 times as big, and it's around the origin, right? I didn't leave one point where it started. Because it's the origin, I had to do it this way. So there's two different ways. When they talk about the origin being the center, you have to take each point and do something to it. And when they talk about this one, where a point is the center, you have to leave that point where it starts and just move the other one. So bring that knowledge with you, and we will talk about it more tomorrow.